Welcome to this Exam Strategy Explainer. I'm so glad you're here. Today, we are absolutely decoding the seemingly complex world of Cambridge IGCSE Mathematics. We're zeroing in on a topic that, honestly, strikes fear into the hearts of so many students: trigonometry. But look, I promise you, by the end of our time together today, you are going to see it not as some confusing jumble of formulas to memorize, but as a beautiful, highly interconnected system. We're going to take the time traveler approach here, working backwards from the perfect exam answer. We'll build it from the ground up, starting with simple, flat shapes on a page and expanding all the way out into the infinite repeating waves that actually map our physical universe. We'll be drawing directly from the Cambridge 0580 syllabus, ensuring you have exactly the strategies and the deep conceptual understanding you need to lock in those top marks. So, let's get into it. Okay, let's dive into our roadmap for this session. First up, we'll establish the right-angled foundation. Second, we'll decode the three trigonometric ratios. Third, we'll look at real-world triangle applications. Fourth, we'll shift gears into graphing the functions. And finally, we'll master solving trigonometric equations. Let's hit it. Section 1. The right-angled foundation. Everything in trigonometry at this syllabus level starts with one perfectly simple anchor: the right-angled triangle. This specific shape is the absolute bedrock of all the calculations we are about to explore. Now, a right-angled triangle obviously has three sides, and to secure any marks, we first need to name them so we know exactly what we're playing with. The hypotenuse is your constant. It is always, without fail, the longest side, and it sits directly across from the 90-degree right angle. Honestly, you can't miss it. But the other two sides, the opposite and the adjacent, well, they are entirely relative. Think of them as shapeshifters. Their names depend completely on which corner angle you happen to be looking from. If you imagine yourself standing at angle A, the side completely across the triangle from you is the opposite, and the side right next to your feet is the adjacent. But if you walk over and stand at angle C, those labels immediately flip. Recognizing this relativity is the very first step to mastering your calculations, and frankly, mixing these up is where I see students bleed points on the exam. But before we get into the new ratios, we have to acknowledge the oldest trick in the mathematical playbook, right? Pythagoras' theorem. It states that for any right-angled triangle, a squared plus b squared equals c squared, where c is that longest side, the hypotenuse. Pythagoras is brilliant. It's reliable, but it has a massive limitation. It only works for lengths. If you have two sides and you need to find the third, Pythagoras is your best friend. But think about the exam. What happens when the examiner only gives you one side and one angle and asks for a missing length? Or what if you have two sides and need to find a missing angle? Pythagoras suddenly can't help us at all. It hits a brick wall. And that exact limitation sets the perfect stage for trigonometry to enter the chat. Moving on to Section 2, the three trigonometric ratios. I really want you to look at these not as scary mathematical spells, but simply as ratios. That's it. They are just fractions. They map a specific angle to the proportions of the triangle's sides. The sine of an angle is just the ratio of the opposite side's length divided by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent side. That is all they are: fixed, reliable proportions. A 30-degree angle in a right triangle will always force the sides into the exact same proportion. It doesn't matter if that triangle is drawn tiny in your notebook or if it's the size of an entire galaxy. The proportion holds. So the crucial point here is this three-step framework. This is your ultimate strategy blueprint for the exam. When you face a triangle problem, do not panic. Work the system. Step 1. Look at your triangle and explicitly identify the side you know and the side you want to find. Label them. Are they the opposite, adjacent, or hypotenuse? Step 2. Look at your three ratios and pick the one and only one that contains both of those specific labels. Step 3. Plug your numbers into that ratio and use basic algebra to solve it. This framework works every single time without fail. Before we continue, subscribe to our YouTube channel ACE Exams at @ACEexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, Section 3, Real-World Triangle Applications. Let's step out of the abstract for a second and imagine this scenario. You are standing exactly 60 meters away from the base of a towering structure. You really want to know its exact height, but obviously you don't have a tape measure long enough to drop from the top. So how do you solve this? This is exactly where your trigonometric ratios transform into real-world superpowers. Now, to solve physical problems like this, we need to understand how we are actually looking at them. In exam questions, they'll use two specific terms you must know: the angle of elevation, and the angle of depression. The angle of elevation is simply the angle above your flat, horizontal line of sight when you tilt your head back to look up, like standing on the ground looking up at the top of our tower. The angle of depression is the exact opposite. It's the angle below the horizontal, when you look down. Imagine you are in an airplane flying at 6 kilometers high, looking down at a boat on the ocean. That downward tilt from the horizon, that is your angle of depression. Examiners love testing if you know exactly where to draw these on your diagram. Let's go back to our tower example. You are 60 meters away. You look up at the top of the tower, and let's say your angle of elevation is exactly 40 degrees. We want the height, right? That's the opposite side from where you're standing. We know the distance along the ground, which is the adjacent side. Opposite and adjacent means we use our tangent ratio. So the tangent of 40 degrees equals the height divided by 60. By simply multiplying our 60-meter adjacent side by the tangent of 40 on our calculator, we effortlessly unlock the answer. The tower is 50.3 meters tall. Boom. No tape measure required, just solid exam strategy. And you know, this brilliant simplicity scales up infinitely. In our source material, we see this exact concept applied to massive, ancient structures, like the Great Pyramid at Giza, which stands 146 meters high. Two observers standing just 25 meters apart on the ground can measure their respective angles of elevation to the peak. Using those angles and the exact same tangent, sine, and cosine formulas we just used on our little tower, they can calculate the exact diagonal distances to the tip of the pyramid, or even the distance to the hidden center of its base. It works for tracking distances between hot air balloons mid-flight or ships navigating the sea. The math remains beautifully consistent. Moving into Section 4, Graphing the Functions. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, we've looked at single triangles locked in place. But what happens when we let an angle grow continuously, from 0 to 90 to 180, all the way to 360 degrees and even beyond? We map these angles on an endless rolling graph, and this brilliantly illustrates the hidden rhythm of trigonometry. Look closely at the sine curve here. As the angle grows, the graph starts at 0, smoothly rises to a maximum value of 1 at 90 degrees, drops all the way through 0 to a minimum of -1 at 270 degrees, and returns perfectly to 0 at 360. Then it repeats forever. Now look at the cosine curve. Guys, it is essentially the exact same repeating wave. The only difference is that cosine starts at a peak of 1 at 0 degrees, dips down to -1, and returns to a peak at 360. They both have a repeating period of 360 degrees. They are twin waves, just shifted slightly out of phase with one another. Now let's look at this comparison table because this highlights the true rubble of the group, the tangent function. While sine and cosine are smooth, rolling waves safely trapped between the values of +1 and -1 and repeating every 360 degrees, tangent totally refuses to be constrained. Tangent has no maximum value. It has no minimum value. It stretches out to absolute infinity. Furthermore, it cycles twice as fast. It has a repeating period of just 180 degrees. Look at the concept of asymptotes because examiners love to test this. Because tangent is the ratio of opposite over adjacent, think about what happens as an angle gets closer and closer to 90 degrees. The opposite side shoots up incredibly high, while the adjacent side shrinks down closer and closer to 0. At exactly 90 degrees, the triangle collapses entirely. You cannot divide by 0. Therefore, the tangent of 90 degrees is mathematically undefined. On a graph, this creates an invisible vertical wall, an asymptote. The tangent curve rockets endlessly upward, approaching that 90-degree line, but it will never, ever touch it. Finally, Section 5, Solving Trigonometric Equations. This is where it all comes together for the big marks. Here is a massive trap in the Cambridge exams. If an exam question asks you to find an angle whose sine is 0.5, and you type inverse sine of 0.5 into your calculator, it will confidently spit out 30 degrees. But we just learned that the sine wave repeats forever. It hits 0.5 infinitely many times, so why only one answer? Well, your calculator has a built-in limitation. It is programmed to only provide the very first primary angle. It is entirely up to you, the student, to use your knowledge of the graphs to hunt down the rest of the hidden solutions. If you visualize the sine wave on a graph and you draw a perfectly flat horizontal line right across it at the height of 0.5, you will immediately see that the line slices through the wave in multiple places. It hits the rising wave at 30 degrees, that's the one your calculator found, but the wave arches over and comes back down, hitting that 0.5 line again before it even reaches 180 degrees. Because the wave is perfectly symmetrical, if it goes up 30 degrees from the start, it must come down 30 degrees backwards from the halfway point of 180. Therefore, 180 minus 30 means that the sine of 150 degrees is exactly the same as the sine of 30 degrees. They are both exactly 0.5. And this brilliantly illustrates the absolute master key for your exams. You do not need to perfectly draw a complicated graph every single time you answer a question. You just need to memorize these symmetrical rules. If your calculator gives you an angle x for sine, the second valid angle is always 180 minus x. For cosine, because of how the wave dips, the rule is different. You map it symmetrically across the 180-degree mark, or more simply, it's 360 minus x. And for tangent, because it simply repeats every 180 degrees, the rule is the easiest of all. You just add 180 degrees to your calculator's answer to find the very next valid point on the cycle. Let's walk through a live example directly from the source material step by step to lock this in. The exam question asks you to solve tangent of theta equals 1/3 for all values between 0 and 360 degrees. Step 1, you hit inverse tangent of 1/3 on your machine. Step 2, the calculator gives you your primary angle, which is 30 degrees. This is where untrained students stop and lose half their marks, but you know better. Step 3, you remember that the tangent graph has a period of 180 degrees, so to find the next valid angle, you simply take that 30 degrees and add 180 to it. Which perfectly reveals our final, complete answers. 30 degrees and 210 degrees. Both of these angles represent the exact same mathematical reality. If you draw a right-angled triangle with an angle of 30 degrees, the opposite side divided by the adjacent side will equal 1/3. If you continue that rotation all the way around the coordinate plane to 210 degrees, the tangent ratio is once again identically 1/3. By following this systematic approach, you work backwards from the mechanics of the wave to mathematically secure every single possible solution. We've journeyed all the way from the rigid hypotenuse of a basic triangle on a page to the infinite sweeping curves of the trigonometric functions. It shows how profoundly this mathematics scales from the exam paper straight to reality. If the simple angles of a triangle can map the endless repeating cycles of our physical world, what other hidden patterns are you missing in plain sight? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.